Hi guys, I'm Angela. I'm really excited to be with you today, and I'm here to talk about how to create single Python executables for easy deployment. So a little bit of background, I'm a software engineer at a small early stage startup called FindMine. What FindMine does is it uses machine learning to automate what is currently a really manual process of curating products together. So our first product completes the look for every item in a fashion retailer's inventory. People want to know, how do I wear this jacket? FindMine says, look, you wear it with these sunglasses, these shoes, these pants. And we found that we help retailers make more money and sell more clothes and help people answer the question, how do I wear what I'm trying to buy online? How it works, we ingest e-commerce retailers' entire inventory. We use machine learning and algorithms to create outfits. We have a content management system so merchandisers can review and still exercise sort of like branding control over their inventory. And then we have an API and a JavaScript module that serves that recommendation upon request for each item in their inventory. The one thing I didn't mention is that we are a very small startup. So when I joined, I was the first engineer. Now we've grown to be about 10 people. So anybody who has worked at an early stage startup will be familiar with all kinds of problems that happen at the very beginning of starting a tech team. And so what I'm talking about today are things that came out of pretty typical startup life problems. So we had lots of them, but let me just tell you about two. So our first problem was that we have multiple applications, 5 different Python applications, 2 open source libraries, a whole bunch of other like scripts and different stuff. And we needed a way to deploy them as a single executable on our production machines with all of their third-party dependencies packaged in. So I'm sure many of you can relate to the frustration. You have some Python software, you try to run it on a new machine, suddenly it breaks, it's missing this dependency. You're saying to your friend, hey, like, what do you have in your pip? Because I have this, and what version is that? It gets exhausting, and when you're a small team, we didn't necessarily have like a DevOps person, so we were just trying to cut down on the time that we were wasting with all these dependencies and managing them. Second problem, which might be familiar to startup people too, is that we didn't have a replicable environment for development and testing. That causes like nightmare problems because we had different versions of our 5 different applications. We had open source libraries with different versions, dependencies within that, and so we had all sorts of coordination, versioning issues, difficult to detect bugs, difficult to run your unit tests and know that they're going to still be true for the production environment. It was a mess. And as our team was growing, we identified that we were going to need to kind of grow up and have a continuous integration practice and solve these problems. So those were the problems. I'm here to tell you about the solution that we came up with. And I know that when it comes to tools and methodologies, people often have very strong opinions. So by no means is this gospel. I'm not trying to sell anyone on anything. Just this is something we did that worked for us. And I hope you guys find it helpful. So 2 things. First, we spent some time, we looked at how other people were organizing their software, and we decided to structure all 5 of our applications into a monolithic code base so that they would all be within the same directory. And then we came up with a unique way to use Bazel and PEX together to solve those 2 problems I've mentioned. So the end result is that we had single executables can run on any machine with all of their third-party dependencies packaged in and a replicable environment for developing and testing. So roadmap for my talk. I'm going to start by introducing you guys to Bazel, which is a build automation tool. Then I'm going to introduce a sample application, which is just to demonstrate this whole process. And then I'm going to talk about PEX and how we use the 2 together. So what is Bazel? Bazel is Google's build tool. It's now publicly available. I believe internally they referred to it as Skylark. It has multi-language and platform support. It has a high-level declarative build language, which is a lot like Python, which is helpful for all of us. It's run as a client server on Linux and Mac environments, so I apologize in advance if you're a Windows team. But once your executable is built, it will run on any platform. So in the bigger picture, Bazel works a lot like Make. Who here is familiar with Make? Okay, awesome. So like everyone. So just super quick. It's a long-time mainstay of the Unix toolset. You basically can specify targets, how those targets depend on other targets, and then what code should be executed when you're trying to build a specific target. And generally, you write the relationships between targets and their dependencies in a makefile. So in Bazel, the equivalent of a makefile is sort of two things. There's a workspace file and a build file. A workspace file is the makefile for your entire monolithic repository, and then a build file is sort of the rules specific to a singular target. The differences between Make and Bazel. First and foremost, Bazel's smarter than Make and makes your life easier. So I'm sure many people can relate to the frustrations of having put something stupid in their makefile and then having to fix it. Bazel simplifies a lot of things. It figures out when and in what order targets should be built. It creates accurate dependency graphs and keeps them in memory, which speeds up builds and allows for parallel execution of certain targets. All you have to do is specify the target you want to build and what that target's dependencies are. In a whole big infrastructure of many, many targets, Bazel figures it out from there. Also, the builds are cached. So if you only touch one tiny component, that's the only thing that's going to get rebuilt. And everything's sandboxed, which is how we ended up with this replicable environment, because we could simulate the sandbox wherever we were. So this is kind of my simple example of what a build file would look like. So you can see here I'm building like these Python libraries. The name is the name of the target, and then the deps are the dependencies that target depends on. So in this situation, wonder depends on not all, lost depends on who, wonder, and are. Bazel takes this information, and if I say Bazel build lost, it'll create this dependency tree. It'll start with not all. It'll parallel execute who, wonder, and are, and then finally it'll give me lost. So FindMind's architecture is complicated. Like I said before, we've got a whole bunch of applications. We've got open source libraries. We've got dependencies. We've got a machine learning module. So I didn't want to go through how we actually use Bazel for ourselves. So instead, I had my incredible intern create an application for the purposes of demoing this. So Krish is an NYU student. He made this application for me. I'm very excited to share it with you. But basically, he wrote a get tweets library, which has a third-party dependency of Python Twitter available on PyPy. Then he wrote an analyze personality application. It relies on the IBM Personality Insights API, and it has two external dependencies, matplotlib and requests. So what the application does is I give it someone's Twitter username, it downloads 300 tweets, feeds it to IBM Watson, tells us all your personality, which is pretty cool. So just quickly, so that you can see how my sample application works, get tweets, as you can see, it imports this Python Twitter library. It gets the last 300 tweets and then returns them using a property. Same thing with Analyze Personality. It imports these third-party requirements. It sends that data that you got from get tweets to the IBM Watson API, and then it spits out at the bottom the needs, the personality values, the needs, the personality, and the values of this Twitter user. So my default user for my application is Donald Trump, the tweeter-in-chief. So you can see here that, let's see, his needs are structure. His personality is extroverted and conscientious. His emotional range is 0.98, very high, etc. So that's Donald Trump's personality. But I'm looking for victims. Would anybody like to have their personality analyzed on the spot? Great. So give me your Twitter handle.
It's just Jared, like Jared.
Okay. Just that?
No, I'm giving you more Jared.
Okay, 1 second. Let me just type this in. Jared.
D, like THE. Sorry, like decoder. It's like Jared the coder. Because there's like 6,000 Jared Smiths in the world. So that's it right there.
Okay, fantastic. I hope I have internet connection. Let's find out. All right, Jared. So your personality. Your needs are love. That seems to be pretty high. Thank you for being so brave.
How many tweets back does this?
300.
This is all just like talk and stock tweets and stuff.
Yep, you're very agreeable, and your values include self-enhancement. Don't blame me, blame Watson if you don't like your. Anybody else want to get evaluated in the back?
The bees.
Oh, you were my my backup in case nobody volunteered. So cool. All right, so it seems, pretty low values in the needs section. Oh no, curiosity is your top one. There you go. And openness. Yeah, so low. I mean, I don't know what to tell you about that, but okay, so that's the application, and shout out to Krish for creating it. So like I mentioned, important thing about Bazel is that everything is sandboxed. So when you think about conceptually, I want to get all these third-party dependencies into my single executable, and I want to get my library, my application, also packaged into this single executable. So the first thing you have to do, whenever you need third-party dependencies, you need pip to install them. So the first thing we had to do was install pip into our sandbox environment. So this is the workspace file for my sample application, and you can see here, the first part is just loading macros, and then that very first macro pip dependencies is the code that downloads pip, pex, setup tools, wheel, and requests into your sandbox, and you need those things to then get whatever else you want. So then pip dependencies itself actually just makes use of Bazel's existing. It has like native rules that have lots of functionality, so we can get a file into a certain folder and make it public, and then we can use that file to install pip and to install all our pex requests, all our other things. Okay, so now let's say we have pip in our sandbox. Second thing we need is pex, and then we need all the dependencies of our two applications. So this, and I'm sorry it's a little bit blurry, but this is the code that basically uses, you can see here we just sort of build up this command, and all it's saying is like get pip and also install these packages, which are the ones I mentioned previously, pex requests, and make sure to install it in this particular directory, which is in the sandbox, rather than like in user bin, and make sure you don't cache anything. So this is to sandbox the installation. And then the second part is going to be looking at these dependencies here, and then making sure that they get downloaded too, using pex. So, using pip. So the important thing here is that in the past, maybe you have a requirements.txt, or you have, wherever you list all your dependencies, now you just list them here, make sure they're the right versions, and you're good to go. So this is the code that then takes pip and uses it to download the binaries of whatever you put in that list in the correct versions. All of this is available on GitHub too, because I know it's impossible to read all of this right now. Okay, so now we have pip, we have pex, we have all of our third-party dependencies. It's time to package all of this into a single executable. And that's where pex comes in. So how many people in here use pex or are familiar with pex? Cool. All right. So I can't explain all of it because it is like a wonderfully, it's a wonderful tool. You can use it for so many things. It has a lot of additional functionality and stuff. But big picture, it's a utility. It was created by Twitter. It's now open source, and it's used for packaging and distributing Python software as single executables. So when you hear of the word like pex file, it's basically a single executable Python software or module. You can specify a lot of things. You can tailor a lot of things. But under the hood, a pex file isn't anything special. It's actually just a zip archive. And the reason why that works and why you're able to run this Python software and make it seem like a single executable is because of the Python importer. So conceptually, if you think about, we're all familiar, I have this file, myfile.py. All it says is print hello world. If I give that to the Python interpreter, it's going to print hello world. If I then put that same text into a folder in a main.py file, give it to the Python interpreter, the importer knows, oh, okay, I've got a directory. Is there a main.py file? Oh, there is. I'll just run whatever's in there. And so you're still going to print hello world. Next up, you can zip that directory that you made, hand it to the Python interpreter. It's still going to know to print hello world because the importer is smart enough to say, oh, okay, it's a zip archive. Well, let me look. Oh, there's a main.py file in a directory. Okay, off I go. And then if you're running on a Unix environment, you can just add a shebang line to the zip itself. And without even specifying the Python interpreter, just make it executable and run it. And it'll know to use the Python interpreter and then run your executable, print hello world. So I hope that made sense, but that's basically how pex does its magic, in the sense that it just creates zip archives with lots of information based on whatever you specify, and then you can just run them, or seemingly just run them. Okay. Any questions on that, or anyone? Cool. So we use that functionality of pex to package all the things that we want into a single executable. And when I say single executable, our Python software just ends up being a zip archive with a fancy main.py file. So then we tell Bazel to build all of this, and we want it to be accurate, repeatable, replicable, sandboxed. So conceptually, the order has to be get pip in your sandbox, get pex in your sandbox, get whatever the get tweets library requires, which in this case was just that Python Twitter library, get whatever the analyze personality application requires, which was matplotlib and requests, then actually build your get tweets library, and this is our build file for get tweets. So like I said before, that's kind of like the make file for the target get tweets. And we wrote this, we wrote this rule ourselves, pex library, and all it does is basically it runs a command, which is pex, gives it all the dependencies, and then tells it where to output it. And it doesn't provide a single executable because it's a library. And then same thing, analyze personality is what I was trying to build in the end. And this is its build instructions. It loads this rule we wrote ourselves, and it tells it to create a binary at the end. So it's pretty obvious in this situation what the order is. This is not exactly like rocket science or very complicated, but you can imagine when you have like all sorts of different applications and all sorts of dependencies, that trying to like figure out that whole graph would be a bit of a headache. So thankfully, Bazel does that all for you, and then can even make you a nice diagram and print it all out. We'll detect if you have any circular dependencies, so on and so forth. So this is how Bazel understands it. The two, downloading the external requirements, can happen concurrently, and then everything else happens in order. So this is just a screenshot of what the build process looks like. And you can see it prints out everything that it downloaded, and it took 54 seconds to get all of that stuff and package it all. And then if I look inside the folder after the build has completed, you can see it generates these 5 new directories. And I made the text really small because it was super lengthy, but those are actually just symlinks to your sandboxed environment that Bazel created. And all of your outputs are in Bazel bin. So then if we go into Bazel bin, has the same structure as my monolithic application structure. And because, like I said, it's a PEX file, you can simply unzip your executable, and it's actually just a gigantic archive. So in case anybody doesn't believe me. So you can see here, this was the outputted analyzed personality executable that I ran to analyze all of your personalities. And now if I unzip it, just everything that we downloaded, the requests library, pi time zones, all the dependencies, everything that we needed is here. So that's how you end up with a single executable. So the impact of this was fantastic for us. Obviously, the problems we were facing were ones we had to overcome, and we had to improve how we were developing, make it easier to work together as a team. And we also really liked the fact that Bazel's supported by Google, and we know that they have so much more functionality built out. So you can kind of rely on the fact that chances are more will get released open source in the near future, and that there's a good support network for that. And yeah, it's fantastic to have a build tool. We can run all our unit tests in this sandboxed environment. It makes deployment super easy. There's really haven't been any downsides, but I would say there were challenges. The number one challenge is just that Bazel's got a little bit of a steep learning curve, and actually so does PEX, I would say, really tailoring so that it doesn't store it in the default directories, but you can actually put it in the cache, etc., or in your sandbox. Took a little bit of figuring out. And with regards to Bazel, it's a little hard to see what's happening sometimes. So you can get some pretty cryptic error messages. And they have great tutorials for Java, C++, but they're still kind of building out their Python support, which is why I wanted to share this information with all of you. Another thing I would say is, I'm trying to think. Yeah, it speeded up our process a lot and gave us a lot more security with deployments. Future bonuses in the future, I'm not sure when, but you can actually do distributed builds and distributed caching of builds. So I know that they have, I believe they've recently released that feature, and I don't know much about it yet, but that's also a huge plus, particularly as our machine learning module grows and becomes heavier and heavier to build. So I'd like to say a big thank you first to my intern who created this wonderful app, and then also to the CTO co-founder of FindMine, Kosta Itskov, who really he really figured out all of this stuff with Bazel and then taught it to me and the team, and then finally to Pi Gotham for having me. It's really exciting to be with all of you. So does anyone have any questions or anything they'd like to ask? Yes.
So is there an easy way to integrate this with GitHub so that somebody could get your entire package but also have version controls?
Yes, in the sense, I think the way we're planning to do it is with Travis CI, or with Jenkins, I guess. So build it out that way. I haven't done it myself, so I can't speak. We haven't got that far, basically. But yes. Yes, in the back.
How does this deal with all of your system compilation dependencies? I find that it installs cleanly, that's nice, but I spend a lot of head banging time and after installing this and finding the header for that and very carefully setting up my SQL, yada yada, like all of those OS dependent steps.
Yeah, I mean, so the benefit with Bazel is that you can actually configure, like you can write your own macro and then specify, like depending on the configurations of the machine that I'm running on, do this, do this, do this, or if it's that machine, do something else. So you still kind of have to go through the work of figuring it out once, but then you can write it into your workspace file, and it will be platform dependent, so it can be dynamic on any configuration. But you would that first time you'd have to figure it out once. But it's nice because then once you figured it out, it really is automated. Yeah. Yes.
It's sort of related to that, but I mean, what is the experience with C extension? So that the two sort of go together.
They have support for C, C++, Java. Bazel does. So I guess in those situations you can, if we have a C++ library that's like nowhere near completed, that someday we want to integrate into this build system. And that was another reason why we liked Bazel, because we had the option to have all these special rules for Python targets that would do all this stuff with PEX. But then Bazel has native support for C, C++, Java.
And it's able to take like the extensions out of the zip file and have them run the
Yes.
zip and C extension.
Yes.
Not friendly.
Yes, in the gray shirt. Oh, you're both gray. Oh, no, sorry, behind you.
So does this, when you go through this process, does it embed the interpreter, or does it still require an external interpreter?
Yeah, you're going to need Python on your machine, yeah. I wonder if there's a way you could configure Bazel to get Python, maybe, but I don't know, but I think that's sort of the minimum. Yes.
Did you compare this against Docker, and if so, why did you go with Bazel? Like, what were the big pros and cons?
We do use Docker for other things, like primarily when we are developing locally, we have like a Docker instance that we do like a database, all that kind of infrastructure stuff. I can't speak to that too much because it was more Costa's decision than mine, but I think one of the big things we liked was just knowing that Bazel was sort of like this offshoot of Skylark, and with the future anticipation that this machine learning app that we have was going to become really heavy to build, we liked the idea of having distributed. I guess Docker could have done the same things for us. So no, there's no like pressing reason why we went that way instead of the other. Any other questions? Cool. Well, thanks so much for coming.